This is Get Ready for Calculus Skill 10, Trigonometry Parent Functions. And we've already done the remember how. We're going to pick up with the rest of the skill here. Let's start with the basic cosine graph. Cosine graphs start at 0, 1, and a full cycle is 2 pi. And so we'll get back up to 0, 1. After that, we can go backwards and do the same. And then we'll just kind of curve it out and make it look decently pretty. And there's a cosine graph. I really encourage you to memorize your sine and cosine graphs as well as your sine and cosine unit circles. That's a different skill though. All right, so what happens whenever we say sine of 2x? The good news is that for mostly in calculus, you don't need to remember all of the nuances of phase shifts and amplitudes and things. But let's just think them through just a little bit. Whenever we're doubling that x, that means instead of a cycle being 2 pi, we're going to fit now 2 cycles in a normal cycle of 2 pi. So if sine normally starts at 0, 0, we're going to get back to a full cycle after just pi, because we're going to try to get 2 cycles in by the time we get to 2 pi. So that means we've got to get up right there at pi fourths, back to 0 at pi halves, and down to -1 at 3 pi fourths. Then that gets us back to 0 at pi, and then we continue the cycle. And so we can do it both directions, and we'll get a nice tighter sine curve because, whoops, got a little crazy there at the end. But there you go. And a nice tighter sine curve looks something like that. Well, what happens when we put a 1/2 on our x? Well, instead of 2 pi, now we only want half a cycle to happen in a normal 2 pi. So if cosine starts at 1, over here at 2 pi, we're not going to end up back at 1. We're only going to make it halfway. So we're only going to get to -1 by then, which means we're going to cross 0 at pi, and we can take it backwards as well. So you get a nice, well, that's not very good. You get a nice wider cosine graph going like that. Tangent graphs don't happen very often at all in calculus, but they could occur, so let's just remember the basics of them. Just a basic parent function tangent graph goes 0, 0. But remember, on our pi halves, our 3 pi halves, and so on and so forth, we have these vertical asymptote lines, meaning tangent does not cross over those. We cannot have tangent at those values. So we're going to cross over at 0, pi, -pi, 2 pi, so on and so forth. And our graph is going to start on the bottom up against that left vertical asymptote line and then go up to the right. So it looks something like this. And of course, it just repeats itself forever and ever and ever. All right, so there's a look at parent trigonometry functions. Let's have ChatGPT tell us a math joke, and let's say about trigonometry, and let's see, maybe it can handle this or not. I don't know. Could be a very advanced math joke. Here we go. Why did the angle go to the beach? Because it wanted to get a tan theta, I'm not sure why theta had to be thrown in there. Hey, that wasn't bad. I feel like I've heard ChatGPT tell me a joke about getting a tan already on another video, so let's try another one. Why was the sine so moody? Because it couldn't find its cosine function. Yeah, okay, that was even worse. All right, well, hey, not guaranteeing great math jokes, but they are generated by AI. That's Skill 10. This is Get Ready for Calculus. Good luck getting ready for calculus. Go to Pythagorean.com if you need PDF files of this to work on, and good luck.